In this presentation you will see how a microprocessor controls a microwave oven. The microprocessor. Many gadgets, devices, appliances and machines have microprocessors controlling their operation. Next, greater than. For a microprocessor to control device, it has two input devices. Input. Process. Microprocessor. Controller system. Output devices. Output. For a microprocessor to control device, it has to detect changes occurring in the system using input devices. Make decisions based on the detected changes. Activate appropriate output devices according to decisions made. Next, greater than. Input, output. Microprocessors control devices using an input/output interface. Fan. Temperature. Sensor. ROM. Output. Input. Microprocessor. Interface. RAM. Address bus. Control bus. Data bus. I/O. There is an output interface for actuating external devices like a motor, and an input interface to monitor external devices like a temperature sensor. Next, greater than. Microprocessor control. Microwave ovens use microprocessors to control their operation. Next, greater than. Components. Here are some of the devices are used in a microwave oven. A microwave generator produces the microwaves that cook the food. A lamp illuminates during the cooking process. A motor drives a turntable so that the food rotates and cooks evenly. A display indicates the cooking time and the selected cooking mode. Next, greater than. A sounder beeps when the cooking period is complete. The keypad enables the cooking time to be set, cooking mode to be entered and start/stop cooking selected. A door switch detects when the door is open. A fan removes steam that is generated by cooking. Next, greater than. To control the operation of the microwave oven, there is a printed circuit board, PCB, containing the microprocessor system. Next, greater than. The power source is a high voltage, alternating current, AC, supply. To power the microprocessor and the various devices, the microwave oven is connected to the power source. The power source is a high voltage, alternating current, AC, supply. The circuitry of the microprocessor and some of the devices require a lower, direct current, DC, voltage. A power supply unit converts the AC supply to the required DC voltage level. Next, greater than. Input devices. The input devices to the microprocessor system are the keypad. The door switch. Next, greater than. Door switch. The door switch requires one input line to the microprocessor system. The input line is a wire that carries an electrical signal from the door switch to the microprocessor system. The switch could be in one of two positions. With the door open, the switch would be open, and with the door closed, the switch would be closed. The microprocessor can determine the position of the switch by the electrical signal on the input line. Next, greater than. Keypad. The keypad has many buttons and requires several lines connecting it to the microprocessor system. For each button pressed on the keypad, a unique digital code is sent to the microprocessor. In this way, the microprocessor is able to detect which button has been pressed. Next, greater than. Output devices. The output devices from the microprocessor system are microwave generator, turntable motor, display, lamp, sounder, fan. Next, greater than. The microwave generator, turntable motor, lamp, sounder and fan each require single-line outputs from the microprocessor. The microprocessor can activate any one of the output devices by sending an electrical signal. for example, to switch the lamp on. There are several outputs from the microprocessor to the display, so that numerous message options can be illuminated. Next, greater than. Question 1. Which device is an input to the microprocessor? A. Lamp. B. Fan. C. Keypad. D. Microwave generator. Question 2. What device generates the low DC voltage? A. Fan. B. Microwave generator. C. Microprocessor. D. Power supply. The connections become confusing to follow when shown all together. Here are the input and output connections to and from the microprocessor. The connections become confusing to follow when shown all together. Next, greater than. If the microprocessor and devices are taken out of the cabinet, we can view the connections more easily. One last important element of the system is a timer for timing the cooking period. An electronic timer is usually an integrated circuit on the microprocessor board. Timer. Next, greater than. Question 3. Which output device requires more than one control line from the microprocessor? A. Lamp. B. Microwave generator. C. Turntable motor. D. Display. System operation. The cooking mode is selected on the keypad and the cooking period set. The microprocessor reads the settings input on the keypad into its memory. Signals are sent to the display to indicate the cooking mode and cooking period set. Next, greater than. Question 4. The cooking mode setting, entered on the keypad, is stored in which of the following? A. In the display. B. In the microprocessor's memory. C. In the microwave generator. D. In the power supply. Processing input. If the start button is pressed while the door switch is open, the microprocessor will detect this and prevent cooking. Not until the door is shut will the computer allow cooking to begin. Next, greater than. Starts the electronic timer with the cooking period. When the start button is pressed and the door is shut, the microprocessor carries out the following. Starts the electronic timer with the cooking period. Switches the fan on. Switches the lamp on. Starts the turntable motor running. Switches the microwave generator on. The microprocessor is able to carry out these tasks very quickly, so they appear to happen at the same time. Next, greater than. The electronic timer counts down during the cooking period. The electronic timer counts down during the cooking period. The microprocessor updates the display every time a second passes. The microprocessor checks for changes which might occur, for example, the door being opened or the stop button being pressed. Next, greater than. It may also put a message on the display, door open. If the door is opened, the microprocessor will detect it and stop the cooking process by switching off the fan, microwave generator and turntable motor. It may also put a message on the display, door open. Next, greater than. If the cooking mode is set to full power, the microwave generator will be on continuously. When the mode is set to defrost, the microprocessor will switch the microwave generator on and off repeatedly during the cooking process. The average cooking power will be less. Next, greater than. When the cooking period is complete, the microprocessor will switch off the fan, microwave generator, lamp and turntable motor. It will then switch the sounder on to let the user know that the cooking cycle is complete. When the door is opened, the microprocessor switches the sounder off if it is still sounding. Next.